All right, so what did everybody get? How much money is 1 kilogram of polyethylene waste worth if we convert it to electricity? You making an answer? Anything?
$1.29.
You got $1.29?
That's what I came up with. I don't know.
Okay, that's about what I got. So here's what we're looking at. We went online, looked up the energy density of polyethylene. We found it to be 45 megajoules per kilogram. We kind of did a rough estimate and said, well, if you had a quarter of a kilogram, that'd be enough to eat for the day, if in fact you could eat it. It sounds about right. Nice little lunch for you, but unfortunately we don't have those enzymes. Now, if we're going to take that and combine it with oxygen and turn it into energy, this is more or less what happens. Those 45 megajoules get converted to kilowatt hours. If we're running at 10 cents per kilowatt hour, I come up with about $1.25 per kilogram. Now, what error did I make there? Think back, Chapter 6, NRGY 101. What did I leave out? Because remember, we're setting this stuff on fire. It's a thermal process, Carnot's law, second law of thermodynamics, can't beat it. Any thermal process is only going to be a 30%, maybe 45% efficient. So you can knock that in half right away, first of all. You can also realize that this is the retail value of energy, and you would have to sell it and compete with, coal. What is the price of coal, by the way? It's $15 a ton. That's what we sell it for, and you can already see that. Well, in some ways, the plastic is actually more valuable. I mean, there's a lot of embodied energy there in that plastic. Coal is just so dang cheap at $15 a ton. It's pretty hard to argue with. So, okay, let's do one more. So we're going to take this and run it for the entire city of Missoula. So let's take 60,000 people, and let's assume that each person generates 7 pounds of garbage per day. And I'm going to take 1 kilogram, turn that into 2.2 pounds, and I'm just going to make a guess. I don't know if this is correct or not. I'm just going to say about 15% of our waste is plastic. Does that seem reasonable based on what we've seen? It might be 10%, it might be 20, but I think that's probably a pretty reasonable estimate. But we're going to get a ballpark here. Let's see what comes out of that. So calculator, let's do 60,000 times 7 times 0.15 divided by 2.2 equals 30,000 pounds of plastic per day. I believe that. Let's see. 30. Yeah, that's about right. I think that's about right. 30,000 pounds. LBS per day, and we'll divide that by 2,000. Sometimes it's easier to think in tons. 14 tons, and that's just 14 pickup trucks. A pickup truck will hold a ton, and I could imagine 14, well, in that sense, it seems kind of small. I mean, that each day, 14 people sitting in 14 trucks could go around and collect all the plastic, but for Missoula, 60,000 people, seems like a reasonable estimate that we've just made. 14 trucks worth of plastic. Okay, so let's now, let's just go back to kilograms and figure out how many dollars worth of energy we're putting in the landfill with plastic. It's kind of, that's sort of the opportunity cost, if you will, if we were to instead take this into a waste energy stream. So let's go back and skip the pounds part. So 60,000. Oh, I'm sorry. No. I'm sorry. This is actually kilograms. Sorry. Let's step back 1 second. Got ahead of myself. Catch me on that next time. So there's 30,000 kilograms. That is 3,000 metric tons per day. Kilograms. So let's actually put that into pounds. So 30,000. 30,000 times 2.2 equals that many tons divided by 2,000. Okay, so it's 33 trucks worth. Now, I said 14 a second ago, maybe it's 33. They're both relatively small numbers. It's somewhere in that ballpark. Okay, so it might be, I'm just going to say 15 to 30 tons per day. We'll just put it in that ballpark. 15 to 30 tons per day. Okay, but if we take this 30,000 kilograms per day, multiply it by the 1.25 times 1.25 equals $37,000 worth of electricity that we could generate per day, 37,000 per day.
Where did you get this
7 pounds per day. The global average for garbage production is about 4.4 pounds. I think this is something we looked at in that first forum. I think the Montana average is something, it's higher. It's closer to 7.
Is global average of what?
I think the global average of solid waste production is about 4.4 pounds per person per day. And the statistics I've seen, Montana is above average in terms of the amount of waste we produce. So it's just a ballpark. Okay, so $37,000 worth of electricity we could be generating. 37.5, and this is before efficiency. We can multiply that by 365. So times 365 equals $13 million. Seems like a reasonable, okay, so there's $13 million per year. Now, I'm going to knock that into 1/3 because of Carno. So Carno's going to take his slice. So Carno, we will multiply that by, let's just say 0.6. So now we're looking at 8 million. Carno gives us 8 million per year. And then I'm just going to knock 50% out of it too, because that's the produced cost. So let's.
How did you get the 37?
37. So this guy is this guy times $1.25 per kilogram. Right, so I took our $1.25 per kilogram multiply it by the 30,000 kilograms estimated plastic waste coming out of Missoula per day from our previous little calculation. So that's our 30,000, multiply that by the 1.25 we got. That's almost $40,000 worth of electricity per day. Multiply that by 365, that's $13 million per year. Carnot has his little slice. I could have taken Carnot's slice out of it earlier, but in any thermal process, that's $8 million per year. And then I'm just going to say cost of business, we can knock that in half, $4 million per year. Okay, so who wants to be a millionaire? All you got to do is collect all the plastic in Missoula, bale it up, and sell it as a waste energy stream. Okay, I'm gonna pause there. I'm gonna do one more calculation because that's not the whole story. I mean, there's a little bit more to it than that. A little bit more to it than that. But that all makes sense, right? I mean, there was no weird hocus pocus. We just got all the numbers straight from utility rates, straight from agreed to energy densities, et cetera, et cetera. We even took a slice out of, for combustion, we took a slice out of cost of doing business, and we're looking at, $4 million a year of energy that goes into the landfill in plastics alone. All right, I'm going to take a quick pause, and I'm going to do a little bit more energy math here.